Hey everybody, this would be if you require any hints or whatever on the Thursday, April 16th assignment. These are word problems, and they're sort of meant to be word problems concerning like systems of equations. Now you could like totally try guessing and checking. And it's very possible that guessing and checking will work beautifully on all three of these. But I guess the hints I'm going to provide in this video would be getting you started on the equations that you could come up with based on the directions. So here's some hints slash spoilers, I suppose, but again, you could totally ignore these equations and just guess and check. You could guess and check different combinations of fancy and plain shirts where you end up spending a total of $131, and there's 7 shirts total. Like, you, just as an example, you could start with, well, what if I bought 4 fancy shirts and 3 plain shirts, because that would be 7 total. And then you have to make sure that was $131 total, like 4 of these and 3 of those, I don't know, or 5 of these and 2 of those, or 3 of those and 4 of those, I don't know. I mean, that's what guessing and checking is. But anyway, the equations, in case you're more comfortable working with the equations, is let's see, what if you said that the number of fancy shirts, like the mystery number of fancy shirts, was F, and the mystery number of plain shirts was P. That would be F plus P. If you added the number of fancy with the number of plain, that would have to be 7. And then as far as like the total number of dollars, I guess you would take the number of fancy shirts, F, and have to multiply it by 28, and then add that to 15p, because it's $15 times the number of plain shirts, and that is supposed to equal 131. And now that you have this system, you can do the substitution method, you can do the elimination method, like get this stuff to line up, and and then make opposites and add them together. Anyway, just a little bit of spoiler alert, like just some hints, some spoilers about what the equations could be, that you could now solve this system by whatever method you want and get the answer. For number 2, and if you think you got enough, then get to work. Or you could pause the video and try to guess what I'm going to say here, but 195 students total. There was 7 total vehicles. Some were cars, some were buses. Find the number of buses they took if each car holds 5 students in each bus. So what's unknown is the number of buses, which we'll call B, and what's also not known is the number of cars, which we'll call C. Now, I do know that when we total the number of buses and the number of cars together, it's again supposed to equal 7. There was 7 total vehicles. So there's one equation that helps tell the story. And now the total number of students, well, there's how many for each bus? So 45 times B, because there's 45 students in each bus, and then 5 students in each car. So we multiply there, and when we add all that up, it should equal 195. And now you can use these equations, the elimination method, the substitution method, whatever, and get your answer for B. On a side note, let's say you were doing the elimination method which means you're trying to add these equations together, but first you need opposites. Anyway, here's my point. If you're solving for b, if all they care about is b, find the number, find the number of buses. So you want b. That's it. You don't even need to know what c equals, just b. So if you're going to do the elimination method, then if you're thinking ahead, you're going to want the c variable to cancel out, not the b variable, if you want to do less work. So you would want to make the opposites with the c's, you know what I mean, before you added the equations together. Anywho, Elisa's printing company. So we have Model A printing presses and Model B printing presses, 70 books a day versus 55 books per day. The company owes 14 total printing presses, and this allows them to print a total of 905 books. How many of each type of printing press do they have? So whatever's not known, whatever they're asking for, that's what your variables have to temporarily take the place of. So let's literally say A and B, right? A would be the number of Model A presses, and B would be the unknown number of Model B. So I know that if I add the number of Model A's with the number of Model B's, how many total printing presses are there? Just how many printing presses are there total? 14. It says it right there. And then if it's 7, so Model A, so 70 books per day, and then 55 books per day for Model B presses, and that's going to total the total books. So that's 905. All right, and then just to kind of refer back to what I was saying in number 2, where all they wanted was the number of buses, and so all you needed to know was B. Well, here they want to know how many of each type. They want to know A and B. So you solve for A, or whatever, you solve for one variable, and then you have to solve for the other one for your final answer. All right?